Hi everyone, I just wanted to take a few minutes to go over a few things with you about the measurement lab experiment. And we'll start out with just a couple slides, then I'll go over some techniques with you that pertain to the lab, and then lastly I'll go over the lab with you. So we're going to start out with just, I think, about 3 slides here. And we're firstly going to talk about reporting scientific numbers. And what you see here is we have a number, so 45.872. And what you see is there are some blue digits and there are some red digits, or there's a single red digit, I should say. Okay, and so you see the words certain and estimated. And what it's trying to tell you is that the first 4 digits in this measurement, these are certain digits. And this last digit, the red digit, okay, this is estimated. And what this has to do with is it has to do with the precision of our measurement. So depending on what instrument we're using, we'll have a different level of precision. And this comes into play when you start getting into things like sig figs and how much precision is in your measurements. And this especially comes into play when you start reporting things in papers and you're saying that I have this level of precision or I have this level of precision. And it all comes back down to exactly what instrument are you using and how precise can it be. And so just taking a look at the simple number, we see that we have 4 digits that are for certain and we have 1 digit that's estimated. And again, that has to do with exactly which instrument we're using. And the better instrument we have, maybe the more precision we have. And let's take a look at 2 examples, and then I'll go over exactly how to do this when it comes to the instruments you'll be using or the ones you'll be looking at for this experiment. Okay, so let's just take a look at a balance. So this is your standard kitchen scale. So not an extremely precise scale or balance, because when it comes to cooking, we don't really need that level of precision. So here we have a balance that's marked to every 1 gram. Okay, and so you see this one is marked in ounces and in grams. And we're going to look at the gram side because we're in chemistry, so we're going to look at grams. If you're at home cooking, you might look at ounces. Okay, but for now, let's look at the grams. And we see that it's marked to every 1 gram. So if you were to go from 0 to 10, and you were to count up all these little dashes, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10. So what that means is that each line represents 1 gram. So suppose I wanted to read this balance, and I wanted to know how many grams of this blue substance. So maybe it's a copper compound, I don't know. Okay, so what I want to do is I first want to just read the numbers. Okay, so first establish what your scale is. That's the very first step whenever you use an instrument and you're going to read it, is you want to establish what your scale is. Okay, so here we just determined that every mark is 1 gram. Okay, so if I was to take a look at this, I would say, okay, well, I can see that it's just past the 1 mark. Sorry, that's not the most accurate line. So I'm looking at this black line. Okay, so it's just past the 1 mark. I can see it's not quite to the 2, so that means it's somewhere in between the 1 and the 2. So what I can do now is I can use my eyes to estimate 1 more digit. So remember, going back to our example here, we had certain digits and we had an estimated digit. So where does that estimated digit come from? Okay, well, this is where it comes from. So we can know for certain the 1. Okay, and they've gone ahead and told us it's 1.2, but I'm going to show you how they got that. So the 1 we know is our certain digit. So now our estimated digit, they say here is 0.2. Well, why did they come up with that? So what you can do is you can mentally divide the lines even further. So you can actually further divide them and say another 10 dashes. So just mentally, you don't actually have to do it. And then you can estimate where exactly is this balance showing me that what the mass is. Okay, and so I could say that maybe it's 1.2 if I said it was maybe 2 marks, my estimated marks, my imaginary marks, past the 1. Or maybe it's 0.3, or you could even say maybe it's closer to 0.1. Okay, so all of those would be okay. So this is sort of where your skill as a chemist or a skill as a scientist would come into play. Okay, so here, let's say that it's 1.2. So remember that this would be our certain digit, so I'll mark it with a C, and this would be our estimated digit, so I'll mark it with an E. Okay, so that's one way, or that's one type of instrument, so that's 1 degree of certainty. Okay, but remember I said depending on the instrument we use, it's going to change exactly how many certain digits we have and how many estimated digits we have. So let's look at another example. Okay, so here now we have a triple beam balance. So you've probably used one of these before. Okay, so again, so first thing, figure out the operation of the balance, of course. Okay, but next we need to figure out what gradings do we have? In other words, what markings do we have on our instrument? Okay, so here we have it going from 1 gram to 2 gram to 3 grams. Okay, so these are all in grams. And then if I look closer, I see that there's 1, 2, 3, 4, 5 to the big dashed line, and then there's 5 more all the way to the 2. So what that means is, so the big numbers are in grams, but the smaller numbers are 0.1 grams. Okay, so I have 10 of those, so they're in the tenths, in other words. Okay, so now I can do the same thing as I did before, only this time, instead of dividing the whole numbers into 10 different marks, it's already been done for me. Now I want to divide the smaller marks into 10 whole numbers, or in 10 divisions, whatever you want to say. Okay, so here again, if I estimate, or if I want to take my marking, so I know that's 1 something. Okay, so I can see the 1 here, so obviously it's past the 1, but not quite to the 2. Okay, then I'll count the number of dashes after that, so 1, 2. Okay, so it's definitely past the 2 and not quite to the 3, so I'll say point, because remember these are tenths, so 0.2. And now in my mind, again, I will divide those equally, and I can estimate my 1 more digit. Okay, so I can actually go to the hundredths position with this. Okay, and you could say it's maybe 0.5, you could say it's 5 marks past, 6 marks past. Okay, whichever one, looks like the most to you. Here they've told us it's 6 marks past, those mental marks that we're making. Okay, so we could say it's a little more than halfway, but not quite, 3/4 of the way. So let's say it's 0.6. Or sorry, 26. Okay, so my final measurement here would be 1.26. Sorry, I didn't mean 0.6. Okay, so just looking at those two examples, it shows you how 2 different instruments, and if we take a closer look at this, remember that these 2 would be our certain digits, okay, and this would be our estimated digit. So in those 2 examples, it shows you how 2 different instruments have a different degree of precision, and also shows you that we actually estimate differently depending on the instrument. Okay, so from here, I want to pivot over to some of the instruments you'll be using in the lab and show you how to do the same thing with those instruments. Okay, so switching over to this, I have a few examples of the different instruments that will be involved in this lab. So I have 2 graduated cylinders, a digital balance, and then a ruler. And I just want to go through relatively quickly how to use each one of these. So even though we have 2 graduated cylinders, just like the 2 balances, you'll see that they're actually estimated differently. The digital balance we'll see is a little bit different than those analog balances we just showed. And then the ruler, well, it's pretty much a ruler, but we'll look closer at it. Okay, so I'll just zoom in on this first graduated cylinder. And this would be, so I don't quite have these marked, but let me grab a pencil. Okay, so this is going to be our 10 milliliter graduated cylinder. So I can probably draw a better M than that. Okay, so this will be our 10 milliliter graduated cylinder. So the first thing we want to do when we are reading a graduated cylinder is we want to find what's called the meniscus. And all that is just the bottom. So if you can see, this has sort of this curved shape. Okay, so the red liquid is just there to help us visualize it. Okay, but what you'll see is you have a meniscus sort of going down, and you always want to read it from this lowest point. Okay, and if you were actually to be reading this, you would want to be eye level. Okay, so you want to kind of hunch down on the bench top, get your eyes level with the meniscus, and then read it from there. You wouldn't want to come from this angle or from this angle, because that's going to skew your measurement a little bit. Okay, so don't do either of those. So let's forget about those. So you just want to get eye level with it. Okay, so we can I'll sort of draw in where you would want to put your eyes. So you want to kind of get on that level. Okay, so let's try to read this. So what we see is that we have liquid in our graduated cylinder. And just like with the balances, the first thing we want to do is establish our gradient. So here we see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 markings, and let's look at the numbers. So it goes from 8 to 9. Okay, good. So that means that if 8 and 9 are a whole number, so they're a whole milliliter, in other words, they're 1 milliliter each, that means in between there, these are 0.1. Okay, so that means I can estimate, just like with the balance, I can estimate 1 digit past that. Okay, so if I was to try to record this reading, so I would say, okay, well, I know it's past the 8, not quite to the 9. Okay, so remember, this is the level I'm talking about. Okay, and now I want to count how many of the 0.1s can I have. So 1, 2, 3, 4, 5, 6, 7. So I see it's past 6, but not quite to the 7. So maybe I'll say it's 8.6 something. Okay, now again, I can divide this, let's just say, in half. You can divide that in half, and half, half, and half. Okay, but again, what you want to do is just divide this with 10 imaginary, and it's hard for me to draw in this, but in your mind, you can divide this into 10 equal sections. So let's just say this is around 8.6, and it looks a little bit lower than 0.9 to me, so let's say it's 8.68. And again, if you read this as 8.69 or 8.67, those would both be correct. Again, this is, how your eyes differ from my eyes, how your estimation differs from my estimation. And so my final measurement for this would be 8.68, and don't forget your unit, which would be milliliters. Okay, so this is your 10 milliliter cylinder. So if you see one like this where you have markings of 8 to 9, which is a unit of 1, and you have 10 dashes in between, that's your 0.1, and then know that you can go 0.01 more than that. Okay, so let's take a look at the next one. So this will represent either your 50 milliliter or, in our particular case, our 100 milliliter. Now this is not to say that all 50 milliliter graduated cylinders or all 100 milliliter graduated cylinders will be marked in this way, but for our particular experiment, this is the way that will be marked. Okay, so if we take a look at this closer, again, first thing we want to do, figure out what our scale is. Okay, so we're going from 20 to 30. Okay, well, that's 10 milliliters difference. So how many marks do we have? Well, they've gone ahead and told us this was 25, so we know that from 20 to 25 is 5, and that's 1, 2, 3, 4, 5 different. And then 6, 7, 8, 9, 10. Okay, so what that tells me now is that these are actually ones. In other words, this is 21, 22, 23. Okay, and then up to 25 and so on. Okay, so how do we read this? Well, to start out with, we know it's a little bit more than 20. Okay, so we'll just start out with our 2 in the tens digit. So we wouldn't write 20 yet because it could be 21, 22, 23, and we know it's less than 30. Okay, so we'll come and we'll say, well, 21, 22, and it's not quite to 23, so I'll say it's 22 something. And now I can go one more, because remember, I can estimate one more digit. So I'm going to say that this is maybe, if I was to divide this halfway, and this is kind of what I like to do, say halfway in between. And again, remember, I'm reading that meniscus, so I'm reading the bottom part of the curve. So I would say that maybe this is around 22 point. I'm going to say it's 22.6 because I feel like it's a little bit higher than 22.5, but I don't think it's any higher than 22.7, let's say. Okay, and so this would be my final answer. I would say 22.6 milliliters. Okay, that's how I read this. And that's for either, again, your 50 or your 100 milliliter graduated cylinder. So the first one we did was for your 10, and now this one is for your 50 or your 100. Okay, so moving on to your digital balance. So this is a lot easier than using your analytical balances. So, sorry, your analog balances, not your analytical balance. This would be an analytical balance. That's the correct way of saying it, or a digital balance, you could say. But since it's so precise, we might say an analytical balance. Okay, so really not a lot to using these. Basically, if you were really using them in the lab, you would find a 0 or a tare button, and you could zero it out, and then you could place your object on top, and then you could read your mass from there. So the important thing here I want to go over with you is exactly how to read these. And we actually don't have to do any estimating here. So all we have to do is look at exactly what the instrument tells us. So we can see it's already in grams, and be careful with what unit it's displaying. Most of the time it's set to grams, but if you, per se, walk into an analytical lab, they might have it set in milligrams, and you wouldn't necessarily know that unless you were to read the scale. So always make sure you read your scale. So if I was going to read this with precision, I would just say it's 34.699 grams. Okay, easy as that. No big deal. Just read it straight off the balance. And make sure that you read all of the digits. Now, if the experiment you're working on doesn't call for that much precision, sometimes it'll say just read 4 digits off the balance or 4 past the decimal, something like that. But generally speaking, it's always a good practice to write down every number the balance tells you, if it's a precision balance like this. That way you can always shorten the numbers or get rid of the precision if you don't need it later. But you can't go back and weigh something once you've done it. I mean, you could if you still had it. But always better to just write down the numbers and then figure out, well, do I really need all those numbers later? So just write them all down. Okay, so that's it with the digital balance, and that's the same as the one that you'll be using in your lab. Okay, so we just have one more thing. So here we just have a meter stick or a ruler in centimeters. Okay, so I'm going to trust that you know how to use a ruler, lining up the 0 with it, all that good stuff. One thing that you will notice in your lab is that they do not necessarily all start at the 0. A lot of them will start at, say, the 2 or the 4. So you would measure maybe this distance. Okay, but just remember, so if my object starts at 2 and ends at 4, okay, I don't have 4 centimeters, I only have 2. Okay, in this case, they've started us at about the 0, so that's good. So I can zoom in a little bit better than you probably can with your eyes, or that you can with what's provided, and I'm doing that simply for demonstration. But again, let's look at our gradient. Let's look at how it's marked. So from 1 to 2, so we know this is 1 centimeter. Okay, so from here to here, we know is 1 centimeter. And if we go 1, 2, 3, 4, 5, so this would be 5, 6, 7, 8, 9, 10. Okay, so my markings, my certain digits, are in this form, x point x. In other words, I have a certain ones digit and I have a certain tens digit. So just like with the balance and with the graduated cylinders, or at least the 10 milliliter graduated cylinder, I can estimate one more digit. So I can have this. Okay, and just using x as a certain digit and then e as my estimated digit. So I could go one more. Okay, so let's take the measurement together of this particular piece of paper or whatever it is. Okay, so we see that it's lined up with about the 0, let's say. Let's just make it easy, and let's say that that's lined up with the 0. And let's take our measurement. So the first thing we see is that it's at least 10. Okay, so it's at least 10 centimeters. Okay, and remember, we can go ahead and write down our 10 since we're not worried about it being 11, because it's not all the way to 11 yet. So we can see that with our eyes. Okay, so now we can estimate our tenths digit. Okay, so we'll say, well, it's 0.5 and 0.6. Okay, so we know it's at least a little bit past the 0.6. Okay, now we can estimate one more digit. Okay, so to me that looks like it's a little bit past the 0.6, but not that much. So I might say that this is 10.61, and then my unit would be centimeters. Okay, so that's how to use the ruler. The balance, I think, probably was the easiest one. And then those two particular types of graduated cylinders that you'll encounter in the lab. Okay, so I want to talk about one more topic briefly because it's used in the lab, and I don't know that you've necessarily talked about it yet, and that is density. Okay, and density is just, okay, so we'll define it mathematically, but first I want to define it just in general terms. So density is just how much stuff is in how much space. Okay, and I like to use this word stuff sometimes in my lectures. And what I mean by stuff, okay, I mean mass. Because remember, mass is, so mass. And just remember that, or what I mean, I guess what I mean to say is not mass per se, but matter. Because remember, matter is just anything that has mass and takes up space. Okay, in other words, it's stuff. Okay, and in other words, density tells us how much stuff do I have in one confined area. Okay, so if I have, 1 by 1 centimeter cubed, how much matter is in that little cube? Okay, so if we define it mathematically, we can say D is equal to M over V. And here M is equal to the mass, in other words, how much stuff, okay? And V is our volume. Okay, how much space. Okay, so that's just our very simplistic definition of density. So how much stuff is in how much space. And so if I want to calculate it, I just take my mass and divide it by my volume. I can also use this formula to do things like this. So say I have my density formula. I have mass over volume. So with this, I could calculate the density of a substance. So I can measure mass, I can measure volume, and in fact, this is what you'll be doing in the lab. So this is how your mass and your volume measurements come together, and they give you the derived unit of density. Okay, so if I have those two things, good, I can calculate density. But suppose I know something's density, but I don't know its mass, but I do know its volume. So I could rearrange this equation to say D times V is equal to M. So density times volume would give me mass. And remember, my units here would be grams, milliliters. So my units of density, if I just write those out, would be grams per milliliter. So here I'm multiplying times milliliters, and just remember that your units have to be the same. So that would give me what? Cancel milliliters with milliliters. That would make grams, which is what? A unit of mass. And I could do the same thing if, for instance, I knew the mass, but I wanted to know the volume. So if I start from D is equal to M over V. So again, this time I want to solve for volume. So I could say times V times V. So now I have V times D is equal to mass. So basically the same thing I wrote above. But now I want to go one more step because I'm looking for volume. So I just divide by density. Divide by density. And remember here, this cancels. So here, this would cancel. So now I have volume is equal to mass over density. And so here my units would be grams per ml. Here my units would be grams. Okay, so these would cancel, these would cancel. And remember that if something is in the denominator, when you bring it to your numerator, you flip it around. So this would actually give me units of milliliters. Okay, so that's just kind of how to find density and ways you can use it. So you could use density If you know mass and volume, you could calculate density. If you know density and you know volume, you could find mass. If you know density and you know mass, you could find volume. Okay, so just very brief overview on density. I'm sure you'll go over it a little bit deeper in your lecture. Okay, and so the last thing I want to do is I just want to jump into the actual lab document and just go over a few things with you, and then pretty much we'll be done. Okay, so now we're back into the Blackboard, and I won't go through this every single time, but remember, just come to the Blackboard, come to the lab section, come down to whichever week, so we're in week 1, and you can double check with the schedule to make sure, and then come to the lab that we're doing. So we're talking about lab number 2. Here you have a video to watch that kind of goes over some of the things I already talked about, but I went into them a little bit more detail than what he talks about. And then down below that, you will see some links to, you'll always have, again, the experiment, sort of reading assignment, and then the lab report. Okay, so the first one, the lab experiment, I already have open for you. Just pull that up. Go back to the top. Okay, so there's some things for you to read about. So there's an intro, some sig fig definition, so explanation. Then it talks about mass measurements, weighing by difference, length measurements. Okay, and then it kind of goes into what I talked about, how to read a meniscus. And again, you can read this for yourself. That's why I'm not reading it to you. Okay, so this is the things you'll read on your own. Okay, and then I'll talk a little bit about density. Okay, so goes into the experimental procedure. So this is kind of how this lab works. So instead of you actually being in the lab taking these measurements, they've just sort of presented you an image to take the measurement from. So the first one will be mass. But then you'll do one with length. So this is what I was talking about. Notice that here this starts at 10 and ends somewhere else. So it doesn't start at 0. So don't tell me that this is 11 point something. Okay, that's not going to be right. Okay, so it's going to be 10, or I'm sorry, or so it'll be 1 point something, not 11 point something. And then same thing here. So don't tell me this is 12 something. So take the difference between the two measurements. Okay. And then you'll come down and you'll read some graduated cylinders. So this is the 10, 50, and the 100. Okay, and you can go back to how I talked about those in terms of reading them. Okay, and then you're going to get into the silver slug. So this is the part where you're going to be getting into calculating density. So you have the mass. Now you're going to determine the volume, and you'll determine the volume by taking the empty graduated cylinder and the final graduated cylinder, okay, and subtracting those two, and that'll tell you the actual displacement of the metal slug. Okay, and from that you can calculate volume. And the last thing it wants you to do is to calculate density. Okay, and then jumping over to your report sheet, you have some pre-lab questions, so go in through and answer these as best you can. Okay, and then you have a place to record your data. Okay, so you have the weight, and then the copper slug, the silver slug, so you can put those measurements in. Okay, green cylinder, blue cylinder, red cylinder. Okay, then you have volume of the solid objects, okay, and then a place for you to calculate your density, and then some questions. Okay. Just jumping back to this, I think I said this is where you would record your volume. I'm sorry, this is obviously the length, not the volume. Okay, the only thing you need to record the volume for is the 3 cylinders and then the volume of the metal cylinder. I just wanted to make sure I clarified that. So it gives you a place to calculate it by the actual measurements, and then it gives you a place to calculate it based on the graduated cylinders. Okay, so I just wanted to be clear with that. Okay, so that will be it for this video. I think I covered everything I wanted to talk about. If you do have any questions, please come see me in my office hours. That's what they're there for. So if you go over this and you're still a little bit confused, please come ask me questions. That's what I'm there for. Otherwise, I will see you next time.